Hello. In this course, I'm going to teach you everything you need to know to get started with Python in Grasshopper. Python is a high-level, object-oriented programming language with dynamic semantics. It's easy to read and easy to learn. It's a widely popular programming language which is useful when developing code in Grasshopper and other libraries that can be used cross-platform. We can use it to automate Rhino and Grasshopper, generate geometries, and some of the key benefits are conditional statements, creating whole functions, and even whole components quickly and easily directly within the Grasshopper programming environment. I'm super excited to get you up and running with Python for Grasshopper, so let's get started. Starting with a fresh Rhino document as well as a brand new Grasshopper document, we're going to go to Maths under Script. We can find our GHPython script component, or we can simply double click the canvas, type in Python, and we can grab one up that way as well. Let's take a quick look at the component itself. Like all other components, on the left-hand side we have our inputs to feed data into the component, and on the right-hand side the outputs, as well as a somewhat unique one where we have the out, where we can put a panel on there. And that one acts as our output. So if we simply double click the icon, we open up our Grasshopper Python script editor. And it comes with some default text that for now we can get rid of. And we're simply going to create our first Python script. So print, open parentheses, hello world, close parentheses. And if we hit F5 or the test button up here, we test and run the code, and we see down here in our output tab, we get the string of hello world, as well as in the Grasshopper environment, our panel also updates with the output. If we zoom in, we can see that we can add and subtract inputs and outputs. If we subtract our output, we can simply right click on the icon and show output out parameter again, which brings it back, so we don't have to worry if we accidentally lose our output. This is of course really great for troubleshooting and testing our code. It's just a way of quickly checking that we're getting what we want. Now, if you have experience with Grasshopper Python, you might know that you can print hello world, press F5, will also work without the parentheses. But there's a reason why I choose to use the parentheses, and that's because, like I said in the introduction, Python is a very flexible, highly popular language that a lot of people use, and we can use across multi-platforms. But PEP 8, which if we check here, is the style guide for Python code. So if you start to use a lot more Python in your Grasshopper and you want to start copying and pasting and making it as flexible as possible, it's important to realize that PEP 8, this is not actually legal Python. So if I load up a command prompt, load up my Python, and let's say I want to simply print hello world, like I've done on line 3 in Grasshopper. It gives me a syntax error, missing parentheses in call to print. Did you mean to use print parentheses hello world? So what's that saying is that this is incorrect. So if I create a big long script with a couple hundred lines of code and I copy and paste it into another Python environment, or I want to send it to a Python environment, I know that this line won't work. Whereas if I use the parentheses, it prints hello world and doesn't give me an error. Now, why does this work in Grasshopper but not in the Python environment? Now, if we look here, we can see that my Python that is currently installed at the time of recording is Python 3.8.10. And if we want to see, a lot of people here think that this is Python 3.8. So if I import sys, which you don't really have to worry about, this is just to demonstrate a point, and I'll import platform as well. And now let's get rid of hello world and let's print platform.python implementation, and I think I'll also print sys.version. If we run that, we get an error because I've got a typo. Run that code, and we can see that this is not Python 3.8. What is embedded in Grasshopper is actually IronPython 2.7. So IronPython is the Python programming language for .NET, which obviously Grasshopper is a .NET environment. You'd know if you make some components or some plugins yourself for Grasshopper that you will do it in C#, .NET programming environment. So when you're troubleshooting your Python scripts in Grasshopper, it's really important just to remember that you want to check if you're getting errors that shouldn't be an error in Python 3.8. Maybe check IronPython to see if there's some sort of syntax error or something that the language doesn't necessarily support. Now that we have a good idea of the version of Python we're doing and we've created our first script, let's have a look at some of the built-in data types that we can use when working with Python. Now, any line that starts with the hash key is going to, of course, be ignored. That's a comment. The compiler will ignore that. I'm going to come down a few extra lines. Print type A. So this is a function that's just going to output whatever the type of data held in variable A. And the first one we're going to have a look at is strings, which we've already used in our first little example, hello world. And if we press F5 to run that code, output is string. And if we put another panel on, we can see that the variable stored in A is the string hello world. Now I've used double quotation marks there, but also legal is, of course, single quotation. So there it updates A is now F. We also have our different types of numbers. So A equals 1. And that is a type int. So that's any full number, any integer. A equals 2048. Also an integer. We have float. A equals 1.2, 1.3. Run that. That gives us the type float. So anything with a decimal point is of type float. We also have complex numbers. So A equals 2.45J. Test that. And that is of type complex. Also, we have Boolean. So A equals with a capital T is true. Run that. And we can see that that's type Boolean, true. Now A equals true. Obviously, I made a point of saying that that's capital. It's because this is case sensitive. If we change it to false, it's type bool. But if we change that to a lowercase f, run that again, we get an error. It's undefined. And finally, we have the none type. So A equals none, which is a special keyword in Python that we probably won't be using in this tutorial as it's a beginner tutorial, but it's important to know that it's there, that we can set a variable as none and then use it at a later date. So these are the basic built-in data types. Now that we've got a good idea of the main basic data types, obviously we don't want to be constantly using single variables, A equals a single integer. We need some way of collecting our data. So Python offers several great ways of collecting data. So the first one being lists, which is probably the one I use most commonly. So if I create A equals open close square bracket, I run that, we can see that we're outputting an object of type list, and A is empty because it's an empty list. We can put some data in there, 2, 3, 4, or 1, 2, 4 more likely. And now we can see that A has multiple lines of data as displayed in the Grasshopper IDE. And we can also see here that at index 0, we have an integer of 1, at index 1, 2, and 4. Just change that to 3 to make it a little bit easier. And of course, it doesn't have to be just integers. We can also have strings, and we can put in a Boolean as well. And that is still legal. So it still outputs multiple different types of data. So some of the characteristics of lists that we have to be aware of is that it's ordered. So if we say print a open square bracket to pull out whatever is at index 1, close bracket, run that, we can see that we're printing whatever is at index 0, which is the 1. We change that to the 1, changes to whatever's at index 1, and 2 changes to the Boolean there, and if we put in the 3, we should get an error, index out of range, that we know that our length is only 0, 1, 2, so it's a length of 3. So if we put length A, we can test the length, and we see that the length of our list A is only 3 items long. So we have 3 points of data in the list A. Not only is it ordered, but it's changeable. So whatever is at index 0 will always be at index 0, but we can change what's at index 0. So I can change that to be 49. Test that. And now we see that what's at index 0 has been changed to the number 49. So that means if we're running some code or doing some tests in our Grasshopper script and we want to be updating based on the data, we can go through our list and update accordingly. And finally, duplicates allowed. So we can also have multiple of the same data. So run that, we don't get an error. We can see that at index 3, 4, 5, we have multiple ones, and that's not a problem. So lists are really powerful that we'll probably use a lot more in this tutorial, but that's just a basic introduction of what we can do with lists. Our next data type is going to be tuples. So a tuple, we simply create, need to assign it with open and close parentheses. So now A is of type tuple, no data again because it's empty. But like last time, we can simply feed it some data, run it, and much like a list, we have our data at indexes 0, 1, 2, and 1, 2, 3. So like lists, tuples are also ordered. So using the same sort of syntax as we did with a list, we can simply print a 2. That should give us the 3. As well, we can have different types of data in a tuple. But unlike a list, it is unchangeable. Now you might be saying you just changed it, but I changed it when we created it. So if I come down here and I try and change index 2 back to a 3, we run that, we get an error. We get that a tuple object does not support item assignment. So that means that once we've created our tuple, we can't change the data in it. Now, this is really good. It's a significant difference from a list because, of course, we might be getting some data from an external source, especially if you're generating some geometry through Grasshopper and you're getting some data from an engineer or a different software package through Python, and you don't necessarily want to change the data that you've been given, but you can still access it and use it for something else. So let's say we want to create a new variable, b equals, And we're going to set it to A1. And then we're going to say B plus equals 2. And if we run that, that should be perfectly legal. Double click on our canvas in Grasshopper. We're going to add another output to our Python component. And we can see that we get 4. So B equals A1. A1 is 2, and then we're adding another 2. We can, of course, always just, if we do it in one line, just go up to 6. We don't need the additional line for a bit more efficient code. So we can pull out the data and do something with it, but we can't change the original tuple. And finally, much like lists, dupes are allowed. So like a list, we can have one multiple times without causing any errors. So similar to lists, but not identical because we have unchangeable. Next data structure type we're going to look at is the dictionaries. So to create a dictionary, we simply use the curly brackets. Gives us type dict. Now, unlike tuples and lists that we've used previously, these aren't indexed by integers. Instead, we give it a key. We separate with a colon, and then we give it a value. So this will be at index key, the key. This is the data in there. So if we print A, all we get is the key. And we can key. And then we print the value that is at the key. So let's say we have model, and say Mustang. If I can type, separate with a comma, year, 1969, make, Ford. We no longer have a key with the name key. Put in a model, and we get Mustang. So, unlike lists and tuples, a dictionary is unordered. Now, if you have a little bit of experience with Python, you might be sitting there going, but Carl, dictionaries are ordered. And I'll remind you that we're coding in Iron Python 2.7, whereas Python 3.7 introduced ordered dictionaries, but not here. We can't just simply pull out whatever is at index 0. It gives us an error. Key error, there is no key. If we change that to the key be an integer, of course it works. But these are not ordered. If you're printing or doing something with the data, it's important to realize that it's never going to be the same. You have to keep track of your keys. And of course, you can put a list in there as well. You can create values of data, which is, of course, super powerful. So at key 0, we have a list of 0, 1, and 2. And then print 0 gives us a list. And then, of course, that can go down to print an additional one, and it just goes at dictionary A, key 0, and in our list at index 1, pull out that data, which is the number 1. Of course, we can change that. So you can quickly start to see how we can build data within our data structures of different levels of dimensions. And then if we're thinking about just pulling data out of buildings, so we could have something like sun values. And on any facade or something like that in a building or any data that we're using, we can then pull out different data types and track it. And depending on what we get, we can have different values. So unordered, and the keys are immutable, which means the keys can't be changed, but the data can. So if we say that we're changing the year, a year, make sure that's typed correctly, equals 1984. Let me just correct that. Get rid of that line because we've deleted the 0 key. Run that again, and now we've updated that. So if we print a year, 1984. Onto our final data structure, sets. Sets is probably the least common I use, to the point where I rarely ever use it. So A equals, now if we do it like that, it defaults to dictionary, some data. It defaults to type set. So empty is type dictionary. I'm not sure if I can do that. Yes, give it an empty list, a none type, and we get an empty, well, there is some data, but it's data of none, a type set. Now a set, so 0, 1, 2. The reason we don't use them, well, I don't use them very often, especially in Grasshopper, is because they are unordered. So if we come down A, gives us an error. Set object is not subscriptable. Whenever we're using this data, we can't guarantee whatever is in index 0 will always be in index 0. And it's immutable, meaning it's unchangeable. So because we've already looked at, we can't check what's at index 2 equals 3. Of course, that's an error. So it's not a very reliable data type for if you want to keep track of what you're doing. And in Grasshopper, it is my least recommended. So now that we've had a good look at the different types of data for collection and subscriptable data types like lists, tuples, dictionaries, let's move over to conditionals. Now we will use our inputs this time. Let's double click and give us a number slider 0 to 20. And we'll simply take that, take our number slider and put it into our variable x. So we can see now, if we print x without declaring the variable, in the programming of this component, it knows that it has an input called x and it passes it through. So we can print type x, and we can see that type x, variable x, is of type float. Because even though we look like we're giving it an integer, it is referring to it as a float. If we right click on one of our input component inputs, we can see here we can give it some tips, whether it's a single item axis, list axis, or a multi-dimensional tree axis. And then type hint, we can tell it, we're actually looking for different types of data that we've already looked at. These are the sort of data types we checked out previously in the tutorial. And then we have some of the Grasshopper, Rhino, geometry data types. So if we choose int, it changes type int, forces it to be type int, and it gets rid of the decimal points on x. So if we want to create a conditional in Python, it's as simple as if, and let's say x is greater than 10, colon, print, yes, x is greater than 10. Run that. Now we see nothing's being printed because Grasshopper Python is checking if x. If x, it's currently not. If we put it above 10, yes, x is greater than 10. And we can say else print no, x is not greater than 10. So now we can come down to below and it checks that. Now we can see here that we have simple, no, it's not greater, it's greater. But if we want to, let's say we want to aim for something like 10, we can add in elif. So that's acting as if this x is 10 spot on. So below 10, greater than 10, 10 spot on. So depending what the input of x is, the conditional is testing and getting it. But what if we want to also get some user input? So let's go back to our, get rid of that, and we'll go back to our a equals hello world. We can run that, and we can see that we have a equals hello world. Now, if we want user input, so get some user input. Now we're going to need to use Rhino script syntax. So what we deleted at the start, import Rhino script syntax. Now we don't want to have to type Rhino script syntax every single time, so we're just simply going to add at the end as rs. Now we can basically do everything we can do in Python, and I mean everything we can do in Grasshopper and Rhino directly from our script editor. So we're going to create a new value variable, and we're going to say name equals rs, and when we hit the dot, the full stop, it gives us some type hints. So if you're not sure what you're looking for, you can go up and down and have a look at what there is. But if you have an idea, you can start typing, and then it's just a matter of going up and down. So we want to get a string, select the one you want to select. So here we want to grab get string, hit the tab button, not the enter button, will automatically enter it in, and then open parentheses because it's a function, and then the script editor automatically jumps over to our help tab, and it gives you some automatic help on whatever function it is that you're using, which is really helpful. 99% of your problems, if something's not working or you're getting some expected this type of data but receive something else, we can check here and it tells us what it wants. So it wants a message, defaults to none, default string, defaults to none, strings none. Pauses for user input of a string value. So reading that, we can say that we can put in, what is your name? And then we can change a equals hello, space, close, plus, and we can concatenate our name, plus, we're excited to say hello. Now when we run, we can see in the Rhino environment, it asks us what is our name. Carl, press enter, and it then changes to hello Carl. If, back onto our conditionals, if name, a. So we test again. What is your name? Greg. Hello, Greg. But what if we don't give it a name? Else. A equals hello. No name. Yes. So we can check if name, if it's got something, else, no name. So, of course, instead of just getting that, we can say number equals, and again, rs dot get int, please enter a number. And then print number times 10. Run our code, pick a number, 9, print 90. So if we need any user input, we can create a variable called number, rs get integer or whatever data type you want, give them a message to initiate and let them know what you're expecting, and then we can do something with that variable. Should be noted that when we create it, it will be there as well. We just need to give it an output. And I bet you it's waiting for another number. Yep. So whenever it runs the script, so the number is a variable that's stored. That's what we've done to it. So we can just say a equals, and now we've put that into a, it's asking for another number. Yeah, this is not very efficient, so I don't really recommend doing this too much. Really, the idea is that all your inputs come from the left-hand side, and then it does what it needs to do and outputs the data. But I think it's important to know that you can get user input. You can do basically everything that you can in Grasshopper as well as Rhino. We can do it directly in Python, which has its benefits. So now it's time, I think, to start generating some geometry. So quickly set up a new setup here like before, but this time we're going to take some custom inputs. So we're going to start with step. We're going to change that to min, and we're going to max here. And then for our outputs, we will have some points and some colors. We can double click, get rid of the rubbish we don't need, test to get rid of that error message, and we are going to do some for loops. So first things first, we've got step equals, we're going to force that to be an int. Same for min equals int min, and max equals int max. Now that's doing the same thing in Python as if you type int here, whatever data it gets in, it's going to do its best to convert that data to this data type. So if we don't have anything in, we're telling it to the step equals convert it to integer step without any data. It says I don't have any data in there. We're going to do our minimum 0, and our maximum we will set to 255. So now we get rid of all the errors because that all works. Now, before we get into our for loops, we have to set up our lists. So as I showed you previously, we're going to set 2 empty lists because we're going to use a for loop to fill our lists. So for x in range. Range is a function to generate a series of numbers. So if I say 10, and then we just say print, we're going to print x. We have a quick look. Make that a bit bigger. Print x, and it gives us 10 data points starting at 0, so that's our first. And the number 9 is the 10th item is number 9, sorry. And if we want to end on 10, we can say, yep, 11 start at 0, but what if we want to start at 1? We can say the minimum is 1 and the maximum is 11. So we start at the number 1 and we finish at 10. But what if we want to go up in step sizes of 2? We can simply say 1 plus 2. Start at 0, might be a bit clearer. 0, 2, 4, and of course that can be any integer, 3. So for the sake of this, we're going to use our inputs. So we're going to grab our min, which is 0. We're going to grab our max, which is 255. And then we're going to use our step, and a little bit neater, for the step size. Now if we print 0, 17, so we're adding 17 each time to our x. Now we're going to repeat that again. For our y value, now we can print x and y. And we can see for each x, so for each 0, we increase y by 17. And then once we've increased all y, we increase x, 17, and then we repeat. So this is a 2-dimensional array. And we can then finally, you might see where we're going here already, do a third one for z. And if we do it again, print x, y, z, you can see that now we're creating lists of 3 items, which we can of course use to add to our list. So to add to a list, we use the name of the list, which is points, function, the method append, open bracket, and we're going to pull Rhino script syntax. So we're going to type in rs, gives us our type hint, add, we know we want to add something and we want to add a point. Then open bracket, it gives us the type hints again down here, points. So we're going to give it the points that we're iterating over, x, y, and z. Close that. And we run the script, and our points are added to our Grasshopper document. So not in Rhino, it's added to this list. We look at the list. We've got all the locations as points. Now we want to do the same thing for the color. Colors.append. But now we want to use the system drawing to generate the colors. So import system.drawing as system drawing SD. We're going to come back to our colors sd.color. And then from our color list, from ARGB will be the one we use. And just like the points, we're going to use our locations to generate our colors. So we lose the errors, but we can see in Grasshopper, in the Rhino viewport, we're getting no difference. That's because we are generating the color values are just coming out as those, but we need to do something with them. So in Grasshopper, you can simply grab a custom preview, and then the material is our colors generated. Just get rid of that and clean this up a little bit. And that is how easy it is to quickly generate custom geometry, as well as adding a bit of material colors so that we can tell them apart. And that's just a real early touch of how powerful IronPython can be in the Grasshopper environment. Let's do something a little bit more in depth. Let's generate some geometry. Let's do custom error messages and probably end up with a function as well as baking out our geometry to Rhino. So I've got a fresh Grasshopper component here, and let's give it some inputs. So we'll start with size X, size Y, size Z, and extent X, extents Y. I think, and then we'll give it some geo for our geometry, and again, let's do some color. I think that's good enough to get started. Okay, let's get rid of everything here. And we're going to be doing Rhino geometry. So we'll grab our rhino.geometry as RG. Then we're going to use system drawing again for our colors as SD. Now, we're going to do some cubes. We're going to color them. And we're going to use our for loops again. So, we'll create an empty list, geo, create an empty list for our color, F5 to run to get rid of that error message, and for X in range, and our range will be our EX. Pass. We're going to get an error. Range, integer, and argument expected got none type. So here we can see that that's giving us a standard Python Grasshopper error as well. But we can actually write our own of these. Like anything you can do with a component, you should be able to access pretty much with Python. And I think it's important to know this because you can quickly create a full plugin, a full component of your own for private use or within your company or school, and you can generate everything, and then you can also have your own custom error messages. So let's do that first. We won't do it for all because we don't want to be here all day. We're going to grab from Grasshopper, I'm going to grab the kernel, import, and you can see all these things that we can import. So obviously, they've given us, McNeil have been very nice and given us access to a lot of things. We're going to grab runtime message level, and we'll import that as RML. Okay. So, we want to test if type EX is not an int, does not equal. So that is our does not equal int try. So we're going to say, let's try something. Try EX equals, like we did previously, int EX. Fix this typo. And if that doesn't work, we're going to pick up an exception, except. So now we want to generate a message. So from the Grasshopper environment, we're going to grab our component. We're going to add our runtime message. And now we need to give it a level. So we've imported our runtime message level above, and it says we can give it blank, error, remark, warning. So we're saying if type X is an integer, try and convert it to an integer. If you can't convert it to an integer, so accept, call up this message. I'm going to say this is an error. And then we can say EX allows only integers as input. And this looks like and we can put in plus, convert it to a string. We're going to grab the type and whatever EX is. So that should be we do need that one. Let's pull this out a little bit, maybe zoom in. It's a little bit bigger. Okay, let's see what happens now. Well, doesn't equal int, EX only allows integers, so we get our custom message. It's not output because it's not an output from Python. This is a Grasshopper runtime message saying that EX only allows integers. So say we give it a number slider 10. Wrong one, EX. I think I'm going to use 11 for extents anyway. So that clears it up. We get no error, it's correct. But what if we put in C plain, construct plain. EX allows only integers as input, and this looks like a type plain. So if we want to say EMR, we can change that to a warning. Oh. And now we can see here that we get the warning. If we can actually, let's make that a bit clearer. Get rid of that. Now where EX only allows integers. So what we can do is we could put this under all this. So if that, and we can go through each element and only run this. We can have a check if, and say we just have some code, all inputs are legal, do something. And that's where we start generating our geometry. But for the sake of this, you can use this anywhere. And we're not going to do this for all 5 because it'll take too long. But that is how we can generate a quick message. So now that we've demonstrated that, we can quickly do this. We're going to keep it square. And we'll make our sizes 10. Size X, size Y, size Z. So we'll put on our custom preview now so we don't have to do it later. And cool. We'll very quickly just switch these to int. Size X we've done. And int. Okay, so we've covered error messages. Check input. Great. Error message if wrong type. Cool. Okay. Especially if you're sharing your code around an office, having something like that is quite important, I think. But now let's generate some geometry. Let's actually do what we're here for, I think. So for X in range, which we've done before, extent is our range. For Y in range and extend Y. We're only doing in 2 dimension to save on computing power and my patience. rg.add point 3D. Oh no, we're not adding because we're in point 3D. We're going to take our X, we're going to times it by the size of the cube we're making, the box we're making. Y times size Y and 0. We don't want to go up in Z. We're doing a 2-dimensional grid. 0.2 equals RG point. And we'll just copy this. And for our one, we want to increase it in the X. Make that a bit clearer. And then for 0.3, RG dot, just copy this one actually. And we're going to increase this one in our Y direction. So we're generating for each of our for loops. We're going to generate it. Now we want to create a plane from these. So rs.add plane not add plane from, points. There, got it. And now we can see that it wants an origin and an xy. So our origin is our point 1. Our x, which we went up in x, is our point 2. And our y is our point 3. Done. We've created a plane. Now we can use this to generate a box. So we're going to append to our list of geometry. We want to create Rhino geometry, and we're going to create a box. Again, we get our type hint. We're not using another box. We're not using a bounding box. We're going to use a plane, x size, y size, and z size, and it tells us what it's looking for. It's looking for an interval. So let's give it what it wants. Generated the plane already, and RG to pull up our interval method. So it's looking for two numbers, a starting float and an end float. So we've already got the sizes of the boxes we want generated here. Top ones. So for the x, size x divided by 2. And actually, we're going to times that by -1. And then we're going to go size x divided by 2, because we want to generate it on the middle of our plane. We're centering the box. Then we need our y interval, which is going to be size y divided by 2 times -1, and size y divided by 2. And finally, our interval for the z height, which will be size z divided by 2 times -1 again, and size z divided by 2. Close our brackets until we get to the end. F5 should have some geometry. Yep, we have some geometry. So if we decrease, perfect. Okay, that's cool. So we're generating the geometry, and let's create our colors. So as before, we're going to append to our color list, system drawing color from ARGB. And for this one, we'll do another little size X. Then we're going to times that by 255 for the RGB. Same for Y times size Y divided by 255, and 150 for Z, since we're keeping it constant. Boom. Yeah, it doesn't like to go over. And I've got that around the wrong way. That should be times, and that should be divide. That should give us a bit more colors. Okay, nice. Okay, so if we go above, we do go out of the range of 255. But that's not a problem. But what I don't really like is how they're perfectly up against each other. So double click my Python again. Let's just make this a little bit smaller. So I'm going to take our 1 to times by minus 0.9. I'm going to grab that. And we might do the same here. 0.9, change that to 0.9. And we'll leave Z the way it is. That just gives us a little bit of distance in between our boxes so we can better see where they start and stop. Okay. That's pretty cool. Now, often one of the first things people do in Grasshopper is an attractor. So instead of keeping this as a static box height, why don't we use the old attractor type to create some depth in the Z. So we need a distance. Can get rid of that for now. Let's put in our point. We'll give that the name point. Let's create a point. Set one point in our geometry. Cool. So now we want to use the distance from the point to say the center, and we're going to generate the height of each box based on the distance to this point. Let's reopen our script. Now we can, for each one, let's create distance and rs.distance, and we're going to use our point, and we're going to grab the rg dot point 3D. Get rid of that, it's looking ugly, get rid of that. X. Actually, we can just use our point 1, can't we? Point 1. So the distance from this point, which is going to be this, to the distance of the point 1. And now for our interval of our geometry, let's, for the second one, distance, and we probably need to maybe just see how that looks. But didn't like that at all. So we've got point 3D. Okay. So we just need to give this a type hint. Point 3D. There we go. So if we change our location of our point, so if anybody saw the little example I put up on my Instagram, this was sort of just how I set that up. I simply put a curve over the top of the area that I was generating our geometry, and then I just animated a point along a curve to create the animation. So that's how simple it is to set up something like that. Sure, you could do this in Grasshopper, but this is really just touching on the basics of the power of Python in Grasshopper. We can do some animation in an upcoming tutorial. We can generate things like cellular automata, but that really depends on how successful this tutorial is. So why don't we keep going with this, and let's add in some additional functions. What if we want to take our, I think that's a little bit high. No, maybe 5 was good. Oh. Bring it down. Yeah, that's cool. Okay, let's have a look at functions. So at the moment, all we've been doing is we've been doing scripts that start from the top, and then they come through and operate through, do the script in order, is what I'm trying to say. We're doing our for loops, we've done our if statements. Let's have a look at generating a function. So we're going to bake our geometry into Rhino, but we only want to bake when we're ready to bake. So we're going to create a new function. We're going to call it baker. Open and close brackets. If you want to import any data, you can put it there, but for this one, we're just creating a blank function. And now we're going to say define baker for k in range, and let's grab the length of our geometry list. So for each element in our geometry, we want to iterate and do something over it. We're going to create a brep, and we're going to use our Rhino geometry rep. We're going to create from box. And we're going to create the box from the geometry, K. So whatever K we're iterating, whatever piece of geometry we're iterating, we're going to create that as a rep. Then we're going to create an attribute, RD, which we don't have. We're going to need to bring in our Rhino doc object. So import Rhino dot a new one doc objects as RD. So now we have attributes, just RD dot object attributes. Open close that method, and now we're going to create an attribute dot color source equals RD object color source dot gonna color from object and attribute dot color object color equals color, and we're going to grab whatever the same list index as our geometry. We'll grab the K, and then we're going to sc dot doc. So script context dot document objects dot add rep. We're going to grab our rep, and we're going to apply the attributes, and that should bake. So if we test, we get no errors, but we can select in our geometry, in our Rhino geometry, and we can see we also haven't baked. So what we've done is we've created a function, but at no point in our script are we calling this function. So let's say we're going to add another input, and we're going to call it bake. And we'll give it a toggle. No, we'll give it a button, sorry. And we'll call that bake. So let's say we don't want to be baking. If this was in our script, every time we updated some data or recomputed, it would be updating and baking. But we want to only bake when we're happy. So maybe when we move our point, we find it in a location where it's satisfied, or you have some sort of Galapagos running through your script and you're saying, yep, only when this condition is met, and our condition is if bake. So if bake is set to true, run baker. And that will, so if bake is set to true, which is just by hitting this button, run this function, so then the script will go find baker and run through this. So if we hit test, and hopefully I don't have any typos, hit bake, and we do have an error. What have I done wrong? So somewhere in here, I see what's happened. I don't have my script context. Yes, I'm not using Rhino script, I'm using script. Import script context as sc. So here I was calling the script context and test, okay. So now we can find an area that we want to satisfy. Okay, so now that we've fixed that error, we can move our point to where we want it to sort of be. Here. And then once we hit bake, if we fix that error, we can hide our Rhino geometry. And now that we can see that we have baked the geometry in Rhino, and not only that, but the display color is set from the Python as well. So we've generated the geometry and set the color as well. And I think that's pretty cool. So of course you could push this a lot longer. In a future tutorial, maybe I'll look at how we can animate and do some more things. I think there's one more thing I'd like to show you that really continues the power of Python in Grasshopper. So, for the last bit of this tutorial, there's one more thing that I think I should show you to get you up and running with Grasshopper Python. And that is, I've shown you how to create pretty big scripts, demonstrating some of the capabilities that really makes Python a great extension to the Grasshopper environment. You get your if conditionals, you get your for loops, we can do while loops, we can analyze data and do one thing if that, or something else if something else. But what if you're receiving some data, you're generating some geometry or you're testing, and then you want to do something that is already in Grasshopper? You can output it from your component into a Grasshopper component, and then if you need to continue with your Python script, you can have another Python script and then continue again, which is not really an efficient way of doing it, which is why McNeil put in place node encode. So what that means is that we can access any of the components that are set in Grasshopper, we can pull them in, we can run them on whatever we're doing in Python, and get the same sort of output. So let's have a look at that. Let's grab divide curve is a common one. So we can imagine that we're getting some data or generating some curves, and then we want to divide that and do something with it, but not just the points, something in Grasshopper. So can we do it all in the one component? So that looks kind of similar. Let's give it the same outputs. And then we're going to increase it as well. We'll give it one more, we'll give it F. Okay. So how can we use this information, this mathematics, this programming inside our Python? First thing we need to do is we're going to import GHPython lib, and we're going to grab the components as GHC. And we're also going to import our tried and true rhino.geometry as RG. Okay. And I'm going to provide some feedback. So instead of the constant print, I'm going to create an empty message. Let's set this up. Let's do a curve. Create a curve on our canvas. Set one curve. And we'll give this to our C input. Right click, type hint, curve. Let's give a number slider for our number. We can give a toggle for our boolean for the kink. And let's quickly check the length of our thing. So it's 233. Let's say start at 150. And PF, let's give that a toggle also. Okay. So for the last one, I just want to make this a little quick just to demonstrate. If it's in Grasshopper, chances are you can access it in Python. So an empty message. If it's GHC. So we're grabbing a component already. We're going to do what I just did in Rhino. I'm going to check the length. Length of my curve. We need to give it the curve, which is our C. If the length, and let's say, if length, I've got to give it what we're comparing it to, is less than the min. So the min is 150. We're going to change our message to equal. The curve is too short. Then we can assume that if it's not too short, we can go straight into an else. We can change our message to equal all good. Then we can change our P, and P is going to equal GHC dot. Actually, let's start with showing how this works. Print component divide, we get our options again. Now it's going to ask for exactly similar to what Grasshopper asks, curve, integer, and Boolean. So if you know, you can sort of know what it's going to do. And then it also tells you what it's going to return. It's going to return points, the vector, the tangent, and the parameters as a number. So this is great information when you're starting out, but we know we've divided curves a million times. So we give it the C, we give it the N, and we give it the K. Where are we getting the error from? Line 12, print. What have we got? We're missing a parentheses. So, we get all of this information. And I'm sure you're thinking to yourself, well, this isn't very useful. So we're getting the vector, we're getting lots of data points. But if we remember what GHC divide curve told us, it said that we're getting a list of information. So again, if we go GHC.divide curve and we open, it doesn't return one thing. It returns 3, and it's ordered. So we can safely assume that it's returning a list, because a lot of everything we do in Grasshopper is lists. So we can P equals, and we can do our C, N, K again, but instead of returning the entire function, we're just going to return the first item in the list. And now if we put a point here, we can drag this out, and we can see that we have 11 points. We can reduce our number. We can see it updates on our Rhino, and the values decrease. So that's perfect. So if we want to generate other data, so we're saving a bit of computing time by not doing anything here. We're going to generate our T, and as above is equal to our output from our Grasshopper component function is 1. We can grab that and do our 2. And because we're using Python, instead of having to grab other components, we're going to add a perpendicular frame. So GHC, let's add a perpendicular frame. We'll use our curve, and now we have our parameters automatically done. And now we can say message equals all good with frames. Obviously, as I work a lot with robotics, I use frames on a daily basis. And now we can simply print message. So instead of ending up with a print of an empty, this printed, whatever we hit, we're only going to print whatever is useful. Just fix our typo. Test again. So now we're generating our divide. And what if we want to generate our perpendicular frames? So we're going to run a robot, which is what I do daily. And we can see, boom. There. Let's say we're doing this for, we're doing something like 5-axis milling, or we've got a building of, 30 stories tall. We don't need to know. All we need to know is that our component works. So at the very end of the project, we can save a lot of computing power, and then we can say, right, I'm going to set this, generate all this geometry. Maybe we have a pipeline that goes 1 kilometer through, and that we generate it at the very end, and then we have our frames done. Of course, this updates. But what if we say the minimum has to be bigger? Oh no, our curve is too short. Bring it down within our range and all good. Now, I know what you're thinking. You can't leave it there. I've created a nice big Python component, but I don't want it to look like the general Python. I want to save the document. I want to give it to people. I want to add it up to my component list up here. You set your own sort of extra sort of component here like I do with other ones. And that is really easy. Create a PNG size 24 by 24 in whatever you'd like. So here I have one I previously made. Simply drag it onto your component and boom. Done. You've got a completely custom component ready to go. Guys, I think that will do it for my introduction to Python for Grasshopper. If you've enjoyed this, all I ask is that you leave a like, consider subscribing, and consider checking out my Patreon. All right, guys, good luck with your modeling.